Hi everybody, I am Lalit.
And I am Vijay. Welcome to the video on the topic how to save power, reuse power and recycle power. We have done a lot of researches on the topic how to save power for the Google Science Fair.
In today's world, power management is a very basic necessity for all the people living in the cities because power has become scarce. Power is not easily available and hence people are suffering. So we came up with the idea to conserve power. Now he'll be explaining it to you.
We have basically got two ideas on how to conserve power. The first idea is that of a Rubik's cube. Using a Rubik's cube you can save a lot of power. A Rubik's cube is used almost everywhere. In every single house Rubik's cube is used. And if a child has craze on how to solve a Rubik's cube, how to finish solving a Rubik's cube, how to find solution for a Rubik's cube, then he has to rotate it for about 1000 times a day. And putting a dynamo for this Rubik's cube saves a lot of energy and conserves power. Now I will be explaining you the diagrammatic representation of the Rubik's cube idea. So here is the diagrammatic representation of the Rubik's cube idea. So a Rubik's cube basically has length, breadth and height which are equal. So we can call it length, length and length. But we will call it as length, breadth and height for now. So using a Rubik's cube, how can you save power? How can you produce power is the question, and I have got an answer for this. So below this one is a diagram that explains how to produce power using a Rubik's cube. So to the height of the Rubik's cube, that is this side, I have attached a dynamo. So this is the dynamo and this has to be rotated to solve a Rubik's cube. So if a Rubik's cube is rotated, this side is rotated almost 1/3 times. So if 3 times you rotate a Rubik's cube, at least 1 time you have to rotate this side. So using this side you can save power. And also it is the same to the other height of it. So there is this height and this height, right? So we have attached a dynamo for this side's rotation and it has to be exactly at the middle of the side. That is because energy gets equally distributed and the dynamo turns properly, producing power. So next, this side's height, that is the height, should also be attached with a dynamo at the center as we had done for this side. So here is a dynamo, as you can see here. I have called it D1 and I have called this D2. So D1 is attached to the center of this side and D2 has been attached to the center of this side. So you can also put another dynamo which is facing vertically upwards facing the other side, but it is not possible due to the lack of space. So that is why I have just put two dynamos to produce power, and as I have told you, it should be rotated 1/3 times to solve a Rubik's cube. So if there is a place where Rubik's cube solving is a craze, then tons and tons of power is produced. So sufficient power is produced so that you can put it in a remote or calculator for it to work. So if you play Rubik's cube for a day, or if you try solving it for a day, then it gets charged so that you can use it for your TV remote or calculator. So attached to these two dynamos is a small cell which gets charged due to the rotation of the dynamo. So here is the cell and this occupies very little space inside the cube. Now we will show you how exactly this idea works. So here is the Rubik's cube model, and as you can see here is the dynamo. So the dynamo, this is the cross section of it. We have removed all the other cubes to show you this. So here is the dynamo. This is actually attached to the middle side, meaning it can either be attached to the middle side or the third side. So if this is attached like this, then the third side moves and the second side should remain constant. So this middle side or the middle height should remain at the same position, and only this third side should rotate to solve the puzzle. So this is a regular process, and only the third side rotates. So hence the dynamo should rotate and should generate power, which is stored in this battery. This battery is actually placed here, but to show you we have done this. So this is the basic mechanism of this, and in the same way the opposite side can also be attached with a dynamo, which works in the same principle. So you implementing this principle can save a lot of power, and the battery can be put in a remote or a telephone or even a calculator, so that it can run easily. And if this cube is played or solved for a day, then it can produce some power that can be used for a remote or a calculator.